The topic I'm going to discuss now is radix sorting, but before I go to radix sorting, I'm planning to talk about counting sort first, because if you understand counting sort first, then you can understand radix sort even better. So how does counting sort work? So how counting sort works is it goes through this list. So for example, if I have an initial list, okay, so counting sort has some initial criteria, like requirements for it to work, right? The requirement is, for example, I have let's say my list is 5 items, right? All the items in this list, okay, should be within a range. So in this case, our range will be from 1 to 4. So all our numbers, if you can see, there is 1, 3, 4. That's the only numbers, and it could also have 2. That's what our range is. So our range is from 1 to 4. All these numbers can be included. Basically, all the numbers within 1 to 4 can be included. This is our range. And so what we do, we make a new array, okay, with that size. So we have 1 to 4, so we make an array with size 4, right? And then we go through this, right? We go through this array one by one. We go to this and we count them. So initially we set all these to 0, right? We set all these things to 0. As you can see here, we set all of them to 0, and then we go through this one by one. So we go to this 4, then 1, then 3, then 4, then 3, and then we count them over here. So when you get this 4, we increment this to 1, then we get 1, then we get here this 1 gets incremented, then we come to 3, then 3 gets incremented, then we come to 4, then 4 gets incremented. So what happens is this becomes 2, right? Then we come to 3 again, so this becomes 2. So then we get this, and then the next we get there is 1 1, there is 2 3s, and there is 4, there is 2 4s, right? And this is what we get initially, right? After this, what we do is we come to each of these and we add that number with the previous one, right? So we have this 1, the 1 stays as it is. Here we'll add 0 plus this number, right? So we get 1 here, right? And then we come here, we add 2 plus this number, which is, we get 3 here. Then we add 2 plus 3, we get 5 here. What this gives us is it gives the index in which where this number will be put next. We'll come to that. So now the next step, what we're going to do is we're going to come to this array, right? We come to this array and we make a new array with the same size, right? We make a new array with this exact same size, and then we gonna go backwards now. Last time we went forwards, but this time we're gonna go backwards, right? So I go backwards. I start here, I go to 3, right? And then I go to index 3, right? Here index 3, and I look at the value here. The value is 3, right? So at this index in this new array, I'll put this value. So this value, so let me just say it again. So there is this red value, right? And there is this blue value, right? So we go to the index of the red value, right? And then we get the blue value. This blue value is the index in here, so it will be here. So we'll put this red value in this index, basically. So this is the index, so we'll put 3 over here, basically, okay? And then we decrement this. So then we decrement this becomes 2, okay? And then in the next, then we finish with this. Then we'll go to 4. We'll do the same thing. We'll go to 4, right? We'll see that it is, the value is 5. So we go to 5 over here and we put the value 4, and we decrement this. This becomes 4, right? So this becomes 4 now, okay? And then we continue. Then we finish with this. Then we come to this one again. So it says 3. So we go to 3 now here, and 3 says the value is 2. So then we go to index number 2 and we put this value over here. We put 3 over here, right? And then we decrement, and we decrement this. This was 2, this was 2. Now we decrement it, becomes 1, okay? Then we finish with this, we finish with this, we finish with this. Now we come to this one and it says value is 1. So we go to index 1 over here. We have value 1. So we go to index 1. In this case, we are starting, all of them are starting with index 1s. They're all starting with index 1. In code, we'll be writing with index 0. And because we start with index 0, we'll have to, when we come to this index, we have to do a -1. But we'll get to that in a bit, maybe, inshallah. So then, yeah. We come here, we put the value 1, right? So we put 1 over here and we decrement this. This becomes 0, right? Well, there's already 0 there, so let's leave it there. Now we come to this last one. So we're done with this. We come to this, we come to 4, and it says index 4. So we put 4 here. And that's how counting sort works. And you can see it is sorted now. And the important point is that it is also stable sorting. What is stable sorting? Stable sorting means, for example, if you look at this, let's say this is, let's say these values, there are repetitions. Like 4 has a repetition. This is the red 4. This is the blue 4. Let's say this is the pink 3, and this is the green 3. and then there will be the 1, so the 1 stays here, and then the pink 3 comes here, the green 1 comes here, then the red, sorry, my bad, green 3, and then the red 4, and then the blue 4 comes here, right? And you can see these two numbers are the same and their order stays as it is. So the red one comes first and then the blue comes in these two numbers, and same thing with 3 as well. 3 pink comes before green. That's what stable sorting means. Now coming to Radix Sort, right? So Radix Sort is a way of sorting, like a method of sorting that we sort from going, like it's for sorting like a big large numbers. Like for example, we have like a number with two, like an array of numbers with like 2 digits, 3 digits, 4 digits, and so on, like big numbers, right? So here we have an example that the teacher has given. So here like we have like one number that's like 3 digit, like this is an array of numbers. It's an array of numbers, and there is like 1 2 3 4 5 6 7 numbers in total, right? So the array, the length is 7. You have like 7 numbers, all of them 3 digit numbers, and we use Radix Sort by sorting from the least significant bit, okay, in this case, which is the rightmost bit, like rightmost digit, basically, not bit, digit, least significant digit, all the way until to the most significant, right? So we start from the right side, and then we sort based on that. We sort based on only that number, right? Only that digit. We sort the whole array based on that digit alone, right? So in this case, this is the ones place, this is the tens place, this is the hundreds place, and so on, right? So first we do least significant, which is the ones place. We sort based on that, and after sorting based on this, we get something like this. If you look at this, we can see that it's all sorted, right? So 0 comes first, then 5, then 6, then 7, then 7, then 9, and blah blah blah. Okay, and it's also and then we sort based on the next most significant bit, right? So then we sort based on the second digit, right? When you sort based on second digit, we look at only that digit, the tens place digit. We look at only that. We sort based on that, like the whole array based on that, right? And then we'll get something that looks like this. You see 2 comes first, then comes 3, then comes 5, and so on, right? And then we go to the most significant bit and we sort based on that, right? We'll look at these digits and we look at them and we sort based on that digit alone, right? So we get 3, then 4, then 6, then 7. At the end of the whole thing, we can see that clearly the whole array has been sorted very nicely, right? The whole array is sorted. Now the sorting algorithm needs always an auxiliary sort as well. So when we sort based on this, when I say that sort based on this, like this least significant bit, in that position, I'm going to use another sorting algorithm, right? So a Radix sort is a sorting algorithm that uses another auxiliary sort, which needs to be a stable sort, right? So what does stable sort mean? As I mentioned earlier when I was talking about counting sort, it is a sorting algorithm that keeps the order, right? So for example, if you look at this, actually there is an example here. If you look at this, where is that? Yes, if you look at this, there's these two numbers, both of them, okay, start with 4, right? So they start with 4. So after the sorting, they come in the same order, like this comes first, then comes this. After the whole sorting, it stays in the same order. So this 4 3 6 comes first, and then comes 4 5 6. Now to explain Radix sort better and how we use counting sort with it, I'll show you an example, right? So let's take this example that was given. So what is the benefit of like using counting sort for us in this Radix sort? The benefit is that the range is limited. The range is always the same because we're going to use only one digit at a time, right? So when we are sorting based on one digit, our range for the counting sort, for example, we are only sorting based on this, right? And in one digit, the maximum number can be is 9. So it can go from 0 to 9. The possible values is 0 to 9. So our range stays 0 to 9. So therefore, our counting array can be of size 10, right? Can be of size 10. So it can look like this, right? Still be our counting array initially. And then in this case, let's do the thing, right? So if we come here, we come to 9, we see 9 is increased, right? So we can come here and we can make this into 1, right? And we can see come to 7 is incremented. You can see there's 7 twice, so I'm just going to do 2. Then again 9 comes, so I'm going to do 2 here. Then 6, I increment 6. Then 0, I increment 0. Then I come to 5 and I increment 5. And then I make this 1, I make this 1 as well. This also becomes 1. This also becomes 1. This becomes 2. This becomes 3. This becomes 5. This becomes 5. This becomes 7. and this is based, like, this is what how we sort based on, right? So then based on this, we'll have, like, after this sorting, after using counting sort, we'll have something that look like, so it'll be 0 5 6 blah blah blah. And this is how we will use counting sort with Radix Sort, right? Now for Radix Sort, now we need to analyze Radix Sort, right? When we analyze Radix Sort, we're taking an example here, right? So for example, here we have, like, we're sorting n computer words. So we have, like, computer words. What are computer words? A computer word is like a 32-bit word, like it's 32-bit binary digits, right? That's one word in computers, right? That's what we call a computer word. So it's like called a 32-bit word, right? So we're going to sort like an array of these computer words. So it's 32 bits, and then instead of doing it like by digit by digit, what they're doing here is we're going to split them into separate pieces. Like, we're going to split them so we can do counting sort how many splits we do. So in this case, like, let's say there's 32 bits and we're splitting it by like 8, 8, 8, 8. So we have total 4 splits, right? There are 4 sections basically. So these sections, so for each section we'll have one counting sort, right? As we saw earlier, for each digit we did one counting sort. For each digit we did one counting sort. For each digit we did one counting sort, right? Similarly, for each of these sections we'll do one counting sort. And here, as you can see, these are 8 digits, right? So in 8 digits, the maximum value in binary we can have is 255, right? And including 0, like 0 to 255. So including 0, there are total possible number is 256. There are 256 values possible, and our range will, and our counting array's range, right, the size of the counting array will be 256 as well. And that's like the so here the value of r is 8 and b by r is 4. So 8 is the number of bits in each section, and b by r gives us how many passes, like how many sections there is, right? Okay, now coming to explain how the running time of, how to find the running time of Radix Sort. First, we need to use the running time of counting sort, because we are using counting sort inside Radix Sort, right? So to explain how it works, so we have that the running time of counting sort is O of n plus k, right, where it goes from 0 to k minus 1, right? And if we have, in our example that we took, right, when we use 32-bit words, if we have each p bit is broken into r bit pieces, right? So if we break it into r bit pieces, right, then we have, what we have here would be, if you look at this, 2 to the power of r. So here, like here in this case, right, in this case, what is the maximum value we have here is 255. Basically the array size will be 256, right? 256 possible values. So that will be the range for the counting sort. That's the maximum range the counting sort can go up to. So it is 0 to 255 basically, right? So basically in that case, it is, what value we have here is 2 to the power of 8. Basically 2 to the power of 8 is equal to 256, right? Similarly, if we have, like, let's say r is 16, like basically r is 16, that means we will be splitting it into 2 pieces, right? And we'll have here 16 instead, 16 and 16. In that case, the maximum value we can put in here will be 2 to the power of 16, which is some kind of, I think it's like around 16,000 or something like that. It's a big value. It's a huge value, right? And that will be the range, basically the range or the counting array's size. So when you're running the counting sort for this position, for this section, the range, basically the size of the counting array will be 2 to the power of 16. So then what it's saying here is, so for each b-bit word that is broken, so when we break it into 2, like for example, we break into 4 sections, right? We break into 4 sections. For this section, for each of them, right, we have to run a counting sort, and that counting sort will take n. So it goes to the whole array n plus 2 to the power of r, where 2 to the power of r is k, which is the range. I hope it makes sense, right? And so we need to go through this how many times? So we do this for each of them. We get that it is the running time is n plus 2 to the power of r, right? Now, but we have, like, let's say 4 of them, right? So we need to do 4 times 2 to the 4 times n plus 2 to the power of r, right? Because we have 4 of them. But what is this 4? How do we get this 4? Basically this 4 is b, which is the size, right, the whole size, which is 32, in this example 32, divided by r. So this 4 is basically 32 divided by 8. In this case, 32 divided by 8 is 4. So 4 is how many passes are there, basically how many sections are there. So what each section is, for each section we'll do one counting sort, right? So that means we have to do 4 counting sorts, right? So for each section, the running time is n plus 2 to the power of r, right? And how many sections are there is b divided by r. Then the total, the running time becomes b divided by r times n plus 2 to the power of r.